Okay, so the test tomorrow follows very much like what you see here in the review. So, guess what? Tonight, could you review for your test? The test has fewer questions than this, so you'll see how long this is, and then it's less than that. There's some substitutions, simplifications, a simple equation, some absolute value equations, some inequalities. That's it, okay? So it follows the sections that we've done so far. So looking at the notes you've taken, pulling up any old videos that I've sent to you, any of that, okay? So at this time, you should have at the top of your page, Chapter 1 test review. And we're just going to do this together, step by step, problem by problem. And that's what I want you to study tonight. Now, when we're done, please take a picture, put it in your Google Classroom, and then you keep your paper so that you have it for a test. And later today, I will post a video of it as well. Okay, take a look at problem number 1. We've got this problem. It is asked us to evaluate x plus y squared times the quantity of 2 plus x if x is 3 and y equals negative 2. So a good idea is to rewrite it on your paper, and then once you've rewritten it, directly underneath it, substitute in the values. Now, if you're substituting in a negative, definitely want to use parentheses. The positives you can or can't, depending on how they're placed. But where we see x's, we're going to replace it with 3. Where we see y's, we're going to replace it with negative 1. That's the one we really have to be careful with when we plug it in. So we're going to get 3 plus the quantity of negative 1 squared times, and if you want to put a little dot there to remind you, that's going to multiply 2 plus 3. Now, if we follow our order of operations, we are going to need to do the power next. And inside the parentheses, kind of there, if you say, please excuse power exponents. This back parenthesis here is a 5. Negative 1 squared is negative 1 times negative 1 or positive 1. And then you are going to do multiplication before you're allowed to add. Be careful, because if you do this addition first, you are going to get the wrong answer. You must multiply first. So 1 times 5 is 5. Our final answer would be 8. So there will be one like that. You are going to just need to replace the values, simplify it using order of operations. Any questions about that one? Okay. Problem number 2 asks us to just simplify. And I'm going to write it over here so I have some room. You write it on your paper. Okay. Now, when you see parentheses, in this particular case, our parentheses, we can't do anything. So when we can't do anything, the only other thing we might be able to do is use our distributive property. Now, what the distributive property says, if there's a number sitting in front of the parenthesis, it implies multiplication, and you are allowed to come into the parenthesis as long as you multiply everything by both pieces. Now, here, be careful, because that's a negative 2. Here, you're distributing a negative 4, so make sure you're distributing the sign along with it so that you don't mess that up. So here, we would multiply that negative 2 twice. Now, if we multiply the negative 4 twice, we get negative 12a minus 4b. Now, we're going to use the negative 2 twice. We're going to get negative 2a plus 10b. So see how those two negatives, the one here and the one here, made a positive 10b. Okay? I tend my next step to do them alphabetically, just so that I won't miss anything. So if we have negative 12a minus 2a, that's negative 14a's. So the reason they had added is if they're the same sign, you add them and keep the sign. If they're different signs, we subtract them and we keep the sign of the larger value thing. So if we look at this next step, see how they're different signs. So we're going to subtract them, get 6. But the 10 wins because it's bigger. And so it's positive 6b's. Now, sometime during one of the last quizzes or things we had, you wanted to try to do something else. This is not an equation. This is not anything that we know anything about A or B. this is as far as you can go. This is your simplification. Stop there. Everybody good with number 2? Okay. What's next? Take a look at 3. It says, if 3m plus 5 equals 23, what is the value of 2m minus 3? Now, there's not a great way to, in this particular one, to convert 3m plus 5 into 2m minus 3. So here's what I suggest we do. Let's go ahead and solve this equation for m first. Let's find its value. Now, that's a pretty straightforward equation to solve. 3m plus 5 equals 23. If you subtract 5 from both sides, we get that 3m equals 18. And then what do we do to that 3 to get that m by itself? Divide it off. So divide by 3. So we get that m is equal to 6. Okay. Now, you'll notice 6 is one of our answers, but here's what I've always told students that are answering a word problem. Read this last part again, because you might have along the way forgot what were they asking? Well, they're asking me the value of 2m minus 3. So 2m minus 3 has a different value depending upon what the m value was. M is 6. So let's take out the m and replace it with 6. Now 2m means 2 times m, which is 12. 12 minus 3 is 9. Our answer is B. Okay? Any questions about that one? There are more than one way to do those problems. I'm just kind of showing you what occurs to me. Okay, let's take a look at number 4. It says solve r equals 1/2 m squared p for p. Now, we're going to have one like this on the test. It is your job to get that p value by itself. So think about, this is the best way to approach it. Look at the other things that are touching it. If that was a number, what does that mean? Is it multiplying? Is it adding? Is it subtracting? What is it doing? So the first thing that's easy to get rid of for this particular problem, and let me write the original underneath it. And writing your original stuff as you go, tomorrow I will give you a blank sheet of paper so that you can write out stuff. But writing the original problem again, always check, make sure you wrote it right. And in this case, I think if you multiply by 2, what's going to easily happen is that 1/2 is going to cancel out. So that's nice, because if the 1/2 cancels out, I know that 2r equals m squared p, okay? Now, if m squared is touching p, m squared p, mathematically, what, if it was a number, what would that number be doing to the p? If it's right next to it like that. It's going to be multiplying, right? So your job is to do the opposite. So what you want to do is you want to do the opposite of multiplication. You want to divide. And when you do that, you get the p is equal to this fraction. Now, I don't know what r is, and I don't know what m squared is, so that is just a what is p in relationship to those other variables, but I don't care. You wanted to know what p was. It's 2r divided by m squared, okay? So that is what you would do for one like that. So just think, if that was a number, what would I do to get the variable I'm looking for by itself? Everybody okay with 4? Okay. The next thing, say to write an algebraic expression to represent each verbal expression. So there is one like this on the quiz. Let's look at number 5. It says twice the difference of a number and 11. So when it says twice a difference, you want to think about it as twice the subtraction of two things. Twice a difference. The difference of what? See how it says difference of? These are the two things that are going to be in our parentheses, a number and 11. Now, if you decide to call it x and 11, y and 11, any kind of variable you want to use there is fine. So that would be your answer. They don't want you to solve it. If they did, they would have to give you more information. Whether it's, they would have to add it with, is equal to, if it's an equation. They would have to say what n the number is or something if it was an expression. So that's all that you have to do. Just leave it. That's your answer. Now 6, let's do the same thing. The product of. So this is the multiplication of. So put a little multiplication dot to remind you what that word means. The product of, multiplication, of a square of a number and 5. Now I'm okay if you just leave it n squared times 5. That's okay. Or you could also write it 5n squared is also perfectly okay. I would accept either one, okay? So you decide how detailed you want to go. But we don't know what n is, so we can't go further. So you are, it is what it is. You're done there, okay? Everybody good with those expression ones? There's very simple ones. I'm going to give you just a very simple one. I think mine, I do write it as an equation, and you got to solve it. But it's, equal. It would be this equals 7. What's the number? Or something like that. Okay. Now, let's look at number 7. 7 is an evaluation. It has an absolute value on it. Let's talk about how to do that. Okay. So we're going to take the y, and we're going to replace the y's that we see with the value of 2.5. Okay. So that's 3 times 2.5 minus 8 plus 2.5. Now, the main thing to remember about absolute values, it is not the positive of all the pieces. It doesn't work like that. It is the positive version of the answer. So let's get an answer first inside the absolute value bars. Then if it's negative, we'll make a positive. If it's positive, it doesn't do anything. It's just positive. Okay. So 3 times 2.5 is 7.5. 7.5 minus 8 is negative 0.5 or 1/2. And now that we have an answer, an absolute value makes that thing inside, and only the thing inside, the positive version of that answer. Well, it's negative, so now it's going to become a positive 0.5. And now we just can proceed with normal good old order of operations. 2 times 0.5 is 1. 1 plus 2.5 is 3.5. So that is what they want there. So the main thing to remember about absolute value, get a number and make that answer positive. Don't make the pieces positive. It is the answer of the absolute value that is positive. Everybody good with 7? And everybody have that written down? Okay, let's take a look at 8. It says we've got this inequality that we want to solve, and then it says graph the solution on a number line. Now I'm going to kind of cut and paste this problem. Well, I'll just write the inequality over here. Okay, so let's take a look at the, first let's solve the inequality. That's what they've asked us to do first off. I don't like when I see that over 5 on that other side. It's not helpful. It's indicating that we're dividing by 5. So what's the opposite of that we could do to get rid of it? We can multiply, right? So I would suggest as a first step in this problem, to kind of really simplify things, is to just put a little multiplication dot. And we'll put that side in parentheses. And multiply by 5. I think that's a really kind of smart way to go. Now, you don't have to. It's just something that I think is a good way to kind of clean up the problem to begin with. So we get negative 10b is greater than 18 minus b. Because these 5's canceled, we don't need those 5 on that other side, so it just becomes that top. Now it's just an inequality. Let's get everything to one side, or the variables to one side. And we can do that by adding b to both sides. And since they're opposite signs, we're going to subtract. We're going to get a negative 9b is greater than 18. And then we have to divide off the negative 9. Now, when we divide by negative 9, what do we have to remember? Because this is an inequality.
The sign flips.
We need to flip that sign. So I'm going to write the negative under here. And then on my paper, I'm going to physically circle it so that I will hopefully remember to flip the sign on the next time I write it. So it's just a little clue, a little hint to yourself. So we get that b is less than -2. Now, these are not done until you have actually drawn out the graph for me. So all I need to see on your graph, I don't know if my graphs have numbers on them, but if you were drawing it by hand, just give me the number below it and the number above it. If you would like putting more on, feel free, but that's about all you really need. And then because there's no equality, put an open circle. If it had that little equal bar, remember, close it in. We want less than. This symbol is shaped like a less than, if I would have drawn it nicely. And so we shade to the left. You can check these pretty quickly. If you I'd pick a nice number like -3. If you put -3 into the original version, it should make a true statement. Everybody good with number 8? Everybody have number 8 copied down? Okay. Next, number 9. It says Carson has $35 to spend at the water park. The admission price is $25, and each soda is $2.50. Write an inequality to show how many sodas he can buy. Well, we know that he has to spend, the amount he spends has to be less than or equal to 35. That's all he's got. Now, he already has spent 25 on the admission. Each soda is $2.50. So let's put 250 times P. Does anybody call it soda around here? Okay, so we'll call it P for pop. Okay, so think about how we would solve 250P plus 25 is less than or equal to 35. Well, it's just a simple inequality. You got to subtract 25. And think about, if you take off the 25, that shows us that we have $10 left to spend on the pop. And so if we divide off the 250, we're not dividing by a negative number, so we don't change our sign. The number of pops that they can purchase, 1050 divided by 250, I think is 4. Let's just check my math before I go on any further. And so then if you say, write an inequality to show how many sodas he can buy, this is the inequality. But if they want you to solve it, that's this. And then you could even put it into words. He can buy 0 to 4 pops. We'll put soda pops. Okay? So that is how you would solve number 9. Any questions there? And there's lots of ways. Some of these you can do, I mean, that you could have done a little bit logically. So feel free if you wanted to solve it a slightly different way, but okay. Now let's move on to number 10. Everybody have 9 before I move on to 10? Okay, let's go on to 10. Here we have an or inequality. It says graph the solution set. So there's our inequality for number 10. When it's an or, you're going to get to solve each one individually. You just get to solve them. So that's great. So let's just pretend each one's their own separate thing. The first one here, we're going to add 3 to both sides. We get r is less than -2. The r's alone, we're done with that one. Now we have a little more work to go on the other one. We're going to subtract 1 from both sides. You get that 4r is greater than 14. And then we're going to divide by 4. Now it doesn't go evenly into 4, or 4 doesn't go evenly into 14. So what you might want to do is you can write it as 7/2 as you want. Now, if you're doing it on a graph paper, it's very helpful to know that that's 3.5. Because we're going to have to actually put that dot on there. And all you have to do for one that doesn't come out great is just guesstimate for me. That's perfectly fine, okay? And then for an or, what's wonderful is that we just, of course, we need -2 on there. And then we just at least need the values in there that would fit on our graph paper. So at -2, we're going to have an open circle and it's less than, shade to the left. At 3.5, we're going to have open circle, shade to the right. So the ors many times, not every time, but most every time, you're going to notice a piece that goes one way and a piece that goes another way. If it doesn't have the equal to, make sure it's an open circle. If it has the equal to bar, color that circle in. Do we have any questions, concerns about 10? Okay. So there's number 10. Let's take a look at number 11. I'm going to write it over here. Now let's look at the instructions. It says solve the inequality and graph the solution set on a number line. Now it is your job between now and tomorrow to make sure you have the rule memorized that if an absolute value is next to a less than, we put the negative on the other side. So I'm going to make a little kind of cheat sheet for you here. You won't get to use it. It's a cheat sheet for your brain to study tonight. But if you have an absolute value less than a number, stick the negative version on the other side. Okay. If you have an absolute value greater than a number, you have two cases. The absolute value is greater than the number, or the absolute value is less than the negative version of the number. And then two little side notes. If you have that absolute value is less than a negative, there is no solution. If you have the absolute value is greater than a negative, the solution is all numbers, all real numbers, which you can write as that double back R. Everybody think it looks like a TR the way I make it, but it's just an R with an extra back. Okay? So those are some little rules to get into your head. Those are some good rules to study for before the test. Okay. So those rules are, again, absolute value less than, you stick the negative version on the other side. Absolute value greater than is an or. If you have absolute value less than a negative, can't happen. Absolute value greater than a negative, all numbers work. Okay, now, that being said, now we got those rules in mind, then we have to apply which rule is it? Well, this is an absolute value is less than or equal to the number 11. So you just rewrite it, and you rewrite the absolute value signal with a negative on the other side. So what's great about an absolute value less than, it's an and, it's an intersection. It is the absolute value stuff is stuck between, in this case, positive 11 and negative 11. And now you just solve it. Now we solve it by, in this case, adding 4. Remember, I say kind of think of it as a 3D equation. You have to add the 4 to all parts of the equation, all dimensions. And so we get -7 is less than or equal to P, which is less than or equal to 15. Now, if you're right, this should follow number line order. That's why you keep it less than. Less than symbols should follow number line order, because this is saying that P is bigger than -7, and also that P is less than or equal to 15, which means it's stuck between those things. So graphing, it's real nice. Just put -7 on there and 15. If you want to color in more, go for it. Are we going to have closed dots or open dots for this particular problem? We got to have closed ones, right? Because we have to have an equal to. Equal to is implied by that coloring it in means I can stand at that location without a problem, and then I shade everything in between. Okay? Makes sense so far for 11? Okay. So now everybody got what they need from this, the little notes. Everybody good with that? Okay. Now let's talk about number 12. It says, which graph represents the solution set to that inequality? So that means solve it. We're going to solve it just like we've been solving before. Okay. So I'm going to write it over here to the side, so I have a little bit of room, if you want to write this down on your paper. It's a between one. We have to get that T in the middle so that it's between two numbers. So we're going to subtract 1 from all the pieces. When we do that, we get 3 is less than 6t, which is less than or equal to 42. Now, that's what 6 t's are worth. We want to know what just t is, so we have to get rid of that front number on the t, and what have we discovered many times now that we got to do to get rid of it? You're going to divide. So let's divide by 6. Now, you have to do all of the pieces divided by 6, please. So 3 divided by 6 is 3 over 6. It reduces down to the fraction 1/2. So I prefer 1/2 or 0.5. If it's a quarter or a half, those decimals are so nice. I'm going to be okay with that. If it's not a nice fraction, just leave it, reduce it, okay? And then we get t, and then 42 divided by 6 is nice. It's 7. And then if we were to draw it by hand, we should have an open circle at 1/2, a closed circle at 7, and we would shade everything in between. So let's see if we can find the picture that has done that. Okay, so we need an open circle at 1/2, a closed circle at 7, and everything in between. H and J are out because they're the ors. If it was an or statement or an absolute value greater than, but it's not. So we need the one with the correct dots. You can tell right off the bat that it has to be F. And even if you look right here, look, open, closed, everything in between, that's the only one that matches. Okay, so there's 12. Everybody okay with that? Do we have any questions or concerns? Okay, let's look at 13. 13 says, Sophia is buying new skis. She finds that the average price is $500, but the actual price could differ from the average by as much as $250. Write an absolute value inequality to describe this situation. Now, we had done some like this where there was like the average price or the kind of ideal situation, and then the range. So this is what I want you to remember there. In this case, this is your ideal or average, and this is your range, or how much variation there might be. Okay? So in this particular problem, they said that the average price is $500. And the wiggle room, the range, is that $250. So let's take out the C and the R and let's replace this. So we're going to put the 500 in the absolute values. We're going to have it equal to how much wiggle room we've got. So that is the writing the absolute value. And the inequality says for average as much as. So let's actually change this equal to. That would be if it's exactly 250. Let's make it less than or equal to 250. Because it's not as, it can't go above that. It's as much as, that's the biggest number we can get. Okay, so now let's solve it. Well, an absolute value less than to me is my favorite because I can just stick the same symbol on the other side and attach the negative to it. So that's what's nice. And then how do we solve that inequality? What do we got to do? What do we got to do to solve that? Got to get the x by itself. So subtracting 500 needs to be taken care of by adding 500 to both sides. Or all three sides. And so we get that our price would be anywhere between $250 and $750. So you could say, it says to describe the situation, if you solved it, you'd say the skis cost between. And you see when we actually are talking about it in words, $250 and $750. So actually writing out what the situation means is a good idea to get used to. We good with 13? You're good. Okay, let's take a look at 14. Let's see. I'm just trying to see how much we should get done today. Okay, 14. It says Andy is making three trapezoidal garden boxes for his backyard. Each trapezoid will be the size of the trapezoid below. He will place stone blocks around the borders of the box. How many feet of stones will Andy need? I didn't put one like this on it, but that's just perimeter. So you're just going to do 8 plus 7 plus 12 plus 7, which is 34 feet. So, but I did not put one like that. But if you want to write down it's 34 feet for your own reference, go for it. But I did not include one like that on the test. Okay. But what I did include were some absolute value equations. Now, on the test, there are 3 absolute value equations. So let's practice those. For an absolute value equation, you got to remember, the main thing to remember is 2 cases. You got to remember the 2 cases, okay? So for 15, when we have the absolute value of x plus 4 equals 3, so there's our original, just write down your 2 cases. So we think of this as the positive case, and this is the negative case. That's the best way. Case 1 is the positive case. Case 2 will be the negative case. The positive case, you just drop away the absolute values, and you solve it. So that's nice. Case 2, you drop away the absolute value, but you make that the negative version. So that's why it's -3 and +3, because it's a directional thing. Where would x plus 4 be? 3 to the left and 3 to the right. And so that's why you get 2 answers. Now, let's solve them. You'll notice the same thing happens both times. Here, we subtract 4 from both sides, but you do here. You just are subtracting from different values. So here you get an answer of -1. Here you get an answer of -7. Now, if it's equal to a positive number, you can check it. It's not a bad idea. You're going to have time to do it because the test has less problems than you see here. So you'll have time in class. If you want to check it, go for it, okay? But they do work if you plug them back in the original. I would always plug it back into the original. Now, 16, same idea. Let's do that one. Case 1 is our positive case. Case 2 is going to be our negative case. Our positive case is when 3m plus 2 equals 1. Same exact equation. Drop off the absolute value. Our negative case is where 3m plus 2 equals -1. So two very simple equations now to solve. You'll notice both equations, we subtract 2 from both sides. And in this one, we get 3m equals -1. This one, we get 3m equals -3. See how it's the same math both times? The first one, we're going to subtract 2 from both sides. Same for the second. Next, we got to divide by 3. So the same algebra is happening both times. You're just dealing with different numbers on the right side. The left one is a little funky. Just leave it -1/3. I'm okay with that. If there was a graph involved, there isn't a graph for these ones, then you would have to get the decimal. But if we don't have to get the decimal, just leave it. Write the word or, and it equals -1/3 or -1. Okay? Let's talk about 17. Earlier, I gave you some information about inequalities, okay? But if you have an absolute value equals a number, you set up the 2 cases. So that's a little note that you can study tonight. But if you have the absolute value equals a negative, then there is no solution. Because this is saying a positive equals a negative, which doesn't work, okay? So if you take a look and you notice, here, let me put that up one more time. So those are some rules that you want to make sure you know for tomorrow, okay? So those are definite rules you want to study. But the thing that you really want to notice about 17 is we're saying that a positive is equal to a negative. And that doesn't happen. There's no solution So you don't have to go any further. You just write the words no solution. You can even write the empty set if you have the urge to write it like that. The problem is for 17. If you went and plugged it back in, you end up getting a positive equals a negative every time, and it just doesn't work, okay? But I want to take a look at why 18 and 19 are different. Do I have one like that? Well, let's just at least do, let's do, actually, we'll skip that one. Let's do 19 and 20. We're not going to do them all. I just want to talk about them just slightly. For 19, yes, it's equal to a negative, but the absolute value isn't equal to a negative. The absolute value minus 6 is equal to a negative. A positive minus 6 could be a negative number, so it's not one that you have to throw out because you technically should add 6 to both sides and get that the absolute value of 5n minus 2 is equal to 3. Then you do the two cases. If you do it, try to make the two cases without doing that, it gets really wonky and weird, and it's hard then to solve. So your two cases, we're not going to finish it, but it's 5n minus 2 equals 3, or 5n minus 2 equals negative 3. That would be your two cases, okay? Let's look at 20. Right now, it's equal to a positive. And so you're like, oh, it looks okay. Well, it's not really. Here's why. It's saying that a positive number plus 9 is equal to 8.
But you subtracted.
But you got to subtract. Let's subtract 9 first. And then we get that the absolute value of p plus 6 does indeed have to equal negative, and there's no solution. So my hint to you there is always isolate the absolute value bars. If you don't, it could throw you all out of whack. So that's always a very good habit to get into. Are we good about our equations? Are you good about the equation ones? Any questions there? Okay. Now we're going to maybe skip a few. Skip 21. Skip 23. Did I ask anything about sets? No, I wasn't going to torture you with that. Okay, let's do 22 and 25, and then we're going to call it a day. Okay, let's do 22. So we have negative 3b minus 5 is greater than or equal to negative 6b minus 13. It says graph the solution set. Solve and graph the solution set on a number line. Let's make sure I write it down right. Okay. So negative 3b minus 5 is greater than or equal to negative 6b minus 13. Okay. So I would probably add 6b's to both sides. So you get 3b minus 5 is greater than or equal to negative 13. Next, I would probably add this 5 so that the b's are on one side and the non-b stuff is on the other side. So we get 3b is greater than or equal to negative 8. And then you divide by 3. Now, negative 8 is not divisible nicely by 3, so just leave it. If you do 8 divided by 3 on a calculator, you get 2.7-ish. So negative 2.7. So that you know where it's at. But you don't have to even tell me that. It's just for your purposes. So we need negative 3 and negative 2 on our number line. Now, the equal to means that we're going to have a closed-in dot at negative 8/3. So it's about there. And I'm just going to allow you, just guesstimate. And then greater than or equal to, shade to the right. Everybody good there? I only have to torture you with one more problem. Take a look at that one. Any questions about that one? Last problem I want to talk about is 25. Everybody have that one copied down? Everybody good? Okay, let's do 25, and then you'll turn this in, and this is what you need to study for tonight. You can look at any of the old videos. I'll send the playlist of all the chapter 1 videos so you have it. Okay, 25. We've got this inequality. It says, for what quantity of beads does the accessory store have a better deal? Okay, so 15 plus 3.25b is less than 20 plus 250b. So the accessory store, you'll see, is right here. We want to know, when is that going to be less than the finishing touch? So that's why it's set up like that. And so you just start solving. Let's subtract 250 from both sides, 250b's. So we get 15 plus 0.75b is less than 20. Subtract 15 from both sides. I'm running out of room. Would be 0.75b is less than 5. And then we divide by 0.75, which is, well, for money purposes, let's go to the nearest penny. Well, no, it's beads. Okay, let me show you what it says. It's 6 2/3. Okay. How many full beads can you buy? Yeah, you have to buy less than 6 2/3. So it would be 6 beads or less. Okay. So that is 25. Okay, so test tomorrow, similar to what you see here, but a lot less. It's a lot shorter than this. At this time, please turn a picture of your work in here. Use it tonight to study. I will post a video, so you've got it. Test tomorrow. It is worth a lot of points, so make sure you study those rules. Okay? And there you go.